Welcome back, 7th grade team. This is Mrs. Allen. I'm a math coach at Bouchard Middle School, and it is my pleasure to continue working with you as we wrap up our series on probability. Our learning target for this week is to investigate and describe the difference between the theoretical probability and experimental probability of an event. Please make sure that you have your supplies for today's lesson. That includes your notebook, your pencil for taking notes and practicing, your calculator, and an I can attitude. We are going to begin with a review of yesterday's independent practice that allowed us to practice comparing the theoretical probability and experimental probability of an event. Number 1 required you to calculate and compare the theoretical and experimental probability of rolling a fair number cube and landing on an even number. Number 2 required you to calculate the experimental probability or relative frequency of an experiment where a number cube was rolled 60 times. It then required you to compare the two probabilities to determine which favorable outcome was the closest to the theoretical probability of landing on the number cube, which was approximately 17%. Now, when we compare the probabilities, we see that the experimental probability of landing on a 5 was 15%, and this was the closest to 17%. Now, number 3 also required you to compare the theoretical probability and experimental probability of finding hearts in a standard deck of cards. Now, you may have noticed the word replacement. Were you able to use your context clues to arrive at a meaning? Replacement simply means to put something back or to return it. In this case, the theoretical probability of 25% is less than the experimental probability of 30%. So please pause the video, check over your work, take as much time as you need, and I'll be here when you return. Today, we will continue our practice in comparing the theoretical probability and experimental probability of the same event. Our vocabulary is a continuation from yesterday. Our terms are theoretical probability, experimental probability, and compare. It is School Spirit Week, and our learning partners for today are Mr. Espinal, Kamari, Hannah, Ahmed, and Christopher from our very own Elkhart Thompson Middle School. Mr. Espinal is a 6th, 7th grade math teacher who has been working with our 6th grade team on RPS at home math lessons. It was exciting to hear that he and many of his students continue to meet to learn math content. Mr. Estimal, Kamari, Hannah, Ahmed, and Christopher allowed us to join them as they practiced a Desmos activity where they describe probability and make predictions. You can see their cool avatars here. The problems they are discussing will appear on the screen. Pause the questions to see what you would select as your answer before they share out. Let's listen in.
First slide, all right, it says, let's play a game. Here's how it works. You'll spin the spinner. How do you win? That's up to you. 2 options. All right, so you could say the spinner lands on red, you win, or the spinner lands on blue and you win. Which option, right? So I see a few of you have already answered, and that's cool, right? And once you submit, you'll be able to see other people's responses, which is pretty cool. All right, so it's more of a collaborative thing. All right, and I see Ahmed says because the red covers more space. Amari thinks red. Anna says red has a bigger probability, and red is bigger, so it has a better chance of landing on red. Good. All right, all good answers. Okay. So let's move on to the second slide because as you'll see, it's all connected. All right. Tells you what you chose. All right, in slide 2. All right, everybody looking at slide 2, you should hit the next button. and then it'll say you chose whatever. Everybody chose red, so it'll say the same. So you're gonna press the spin, all right, and I want to share what you finished with. Okay, so if you want to say it out loud, you want to unmute your mic and say it out loud, that's fine. Or if you want to type it in the chat, what you got, that's fine as well. Blue one for you, Ahmed? Yeah. Okay. All right. So
Red.
Hannah landed on red. Good. Kamari landed on red. Christopher, what did you land on?
Red.
Okay. So as we can see, almost everybody landed on red, except for Ahmed, all right? But what we notice here is that it's not a perfect system, right? Even though you had a better chance of winning with red, that doesn't necessarily mean you're going to land on red, okay? So probability is just that. It's about chances. It's about the, well, let me save my words. I'll let you share them. All right, and let's see what happens here. In slide number 6, it says, how likely is each event? Drag the movable points along the probability scale to indicate your answer. All right, so here you're going to be sliding the tab for the red and the blue to where you believe they belong. And I'm seeing you guys' responses, and very good. Okay, you want to have, all of you seem to have done the same thing where you have the red about 3/4 of the way, 3/4 of the way, 75/100ths of the way, and the blue should be at 25/100ths or 25%. So very good. All right, this looks really accurate. You guys seem to have a good understanding on probability, which is good. You guys bring that skill right along into middle school, and that's great. All right, I like your answer there, Ahmed. For red is more likely because it's more. Blue is less likely. All right, so I like the wording, the likelihood of things happening, the likeliness of it, right? So very good use of vocabulary there. Red has more spaces, blue has less. Very good. And what if I were to ask you guys, all right, what is the percent chance of landing on red? What would you say if I asked you, what is the percent likelihood of landing on red? What would you say?
85.
85%? Yeah. There you go. Yeah, it's 75%, right? When we're talking about 3/4 of the way, now that's the likelihood of it, right? That doesn't mean that's it. If you do 100 spins, it's going to exactly be 70 times. But the likelihood of it happening is 75% chance, right? 3 out of 4. So most of you guys seem to have picked the one that's half and half, all right? Almost red and almost blue. Why would you, half of it red, half of it blue? Why would you say that? If you want to chat it or just say it out loud.
I picked all of them.
Okay, you have to pick one of them though. Which spinner did they most likely use? So you want to try and choose one here. And there's really 2 possible answers. Okay, there's 2 that's incorrect. And then there's 2 that can definitely be correct, all right? So I'm looking at it, and it seems either you chose the one that has 4 parts, 2 of them blue, 2 of them red, or 2 parts, one of them red, one of them blue. And I'm trying to figure out, you guys are correct. I just want you guys to explain, how did you know? Like, what made you pick that? You can unmute or you can chat, however you want to share your answer.
Because they're both near the half and half.
They're both near half and half. Absolutely. I get what you're saying there. All right.
I picked the top one because it covers more ground.
Covers more ground in which color?
In blue.
Oh, I see what you're saying. Now, that first one, though, however, that would really show that it's a 75% chance of being blue, right? And a 25% chance of being red. Whereas the other options, they're like equally likely, okay? You have the same amount of chance of getting on red as you have on blue. All right, and 19 out of 36 is pretty close to half. What would be half of 36?
18.
18. Yeah, and these guys, they were really close. 17 red, 19 blue. All right. So let's go to the next slide. Let's go to slide number 11. All right, so here you're trying to match each scenario with the appropriate teal and orange colors, orange cards, excuse me, from the probability scale. So here you're trying to match all three together, and I already see some of you getting matches already, and that's great. Very good. All right, so while you're doing that, I'll give you a few minutes with that, and then what I'm gonna do is I'm gonna set up a GIMP kit to close out our class here.
Did you notice how Kamari, Hannah, Ahmed, and Christopher made observations, calculations, and predictions based on the spinners and their activities? Did you think of the probability line as you were listening to them describe the likelihood of some of their outcomes? The link to their activity will be at the end of the lesson and on your learning plan if you would like to practice as well. Next, I want you to think back to the first day of our probability series when we were introduced to the probability line as a visual that allows us to see or represent the probability of an event on the number line. We can also use a probability line to compare different probabilities. Let's start by visiting with RJ and Sam at Study Jams for a quick review of calculating probability and a segue into how to compare probability.
Sam and I were hanging out before school. Sam said that if I pulled a jack out of the deck of cards on my first try, he would buy me lunch. But if I didn't pull out a jack, I would have to buy him lunch. Before I jump into this deal, I want to calculate the probability. First, find the number of favorable outcomes. I know that each deck of cards has 4 jacks. That means I have 4 favorable outcomes, or 4 chances. Next, we need to figure out the number of possible outcomes. There are 52 cards in a deck, and I have an equal chance of picking any one of them, so that means there are 52 possible outcomes. Probability can be expressed as a fraction. Place the number of favorable outcomes over the total possible outcomes. So our fraction is 4 favorable outcomes, me picking out a jack, over 52 total possible outcomes, all the cards in the deck. The probability of me picking a jack is 4 out of 52. We can reduce that to 1 out of 13. Those odds don't sound too good to me, so I think I'll pass.
So the question on the floor, should RJ accept Sam's challenge? Let's use the number line to compare RJ's chances of picking a jack with Sam's chances that he won't pick a jack. Let's place the probability of RJ picking a jack on the number line. So remember, the probability of picking a jack is expressed as our ratio. There are 4 jacks in a standard deck of cards with 52 total possible outcomes. And this simplifies as 1/13, which is approximately 8%, which is probably 8/100 as a decimal, and 8%. And we will plot the probability of selecting a jack on the far left-hand side of our probability line. Now, what we see on our existing line here, we first see that we have a number cube, which has a 1 in 6 chance of landing on one particular side, which is approximately 17%. So we know that 8%, which is the probability of choosing a jack, would be to the left-hand side of this. It's closer to impossible, so approximately right here will be the probability of selecting a jack. That's 1/13. And converting your fraction into a decimal or percent can assist you in your placement on the number line. And it's okay to choose which representation works for you because equivalent fractions, decimals, and percents, they all have the same value. Next, we want to represent our second fraction on the number line, which is the probability of RJ selecting a card that is not a jack, because remember, that would be in Sam's favor. So the probability of selecting a card that is not a jack, and in this case, again, we would call this the complement because it's the opposite of the probability of a jack. We would have our ratio, which is 48 cards in a deck are not going to be a jack out of 52 total possible outcomes, which simplifies as 12/13. And we can convert it into a decimal using your decimals calculator, which is 92/100. Or as a percent, it'll be 92%. And we would plot this on the far right-hand side of our probability line. And we see right here, we have the example of selecting a red ball from 8 or 5 total possible outcomes, which is 80/100. And in this case, we want to represent 92/100 or 92%, which would be to the right of that. So this would represent the probability that it's not a jack. And you said that would be 12/13. So when we compare the two probabilities, we can see that Sam's probability is really close to certain. And again, his probability is that it's not a jack. That's what he wants, which would be in his favor. And Sam told RJ that if he pulled a jack out of a deck of cards, he would buy him lunch. But if Sam didn't pull a jack out of the deck of cards, he would have to buy Sam lunch. Now, because RJ did the math, he was able to discover that Sam's challenge was not in his best interest. Sam has a much better chance of RJ having to buy him lunch because the probability of selecting a card that is not a jack rather, is greater than the probability of selecting a card that is a jack. And this is an example of comparing theoretical probability. Now, we can compare experimental and theoretical probability in the same way. The only difference is that we are comparing actual outcomes of an experiment, which is the experimental probability, to what we know about what could happen if we did a trial, and that's the theoretical probability. Now it's your turn to try. Pause the video and then return when you're finished, and we'll see how you did. So let's take a look and see how you did. We have a spinner shown and it's divided into 6 equal sections, 1, 2, 3, 4, 5, and 6. A student spun the spinner shown. The arrow landed on the number 1 4 out of 10 times. Is the observed frequency different from the result expected from the theoretical probability? Explain. So again, we applied cubes, our problem-solving strategy, where I underlined the question and I circled the numbers. We have one term which is observed frequency, and that would be our experimental probability. What we observed took place in the experiment. And then we have expected, and that represents our theoretical probability. So we're calculating the two probabilities. First, we see for the theoretical probability, the probability of landing on a 1 is 1 out of 6, which is approximately 17%, 17 hundredths. And then we have the experimental probability, which is our observed frequency, and the probability of landing on a number 1 is 4/10, as the word problems told us, and 4/10 is 40%. And so when we compare the two, we see that the expected frequency, again, which is 17%, is less than the observed frequency of 40%. Our learning objective was to compare the theoretical probability and experimental probability of the same event. Feel free to return to this slide with the vocabulary terms should you need to review these concepts. It's that time. Let's reinforce the content that we learned today by doing our independent work located in week 8, day 4 of your learning plan. Remember to show your work and annotate. When you're finished, strengthen your math skills by completing 2 Dreambox lessons. And here is the code if you would like to try the Desmos probability activity that our learning partners, Mr. Espinal, Kamari, Hannah, Ahmed, and Christopher practiced when they were working with us today. You can work through the activity independently and type your answers in for others to see. Let's take a look at our future connections. Today's learning objective was to compare the theoretical probability and experimental probability of the same event. Tomorrow, we will wrap up our 2-week probability series with a cumulative review. Remember to share your avatar and upload your probability experiment to our Padlet. Mrs. Allen finally got around to creating an avatar, and there she is. I'd love to see yours too. I thank you for being my learning partner today. I want you to be safe. I look forward to seeing you tomorrow. And remember, that's right, make today so awesome that yesterday gets jealous. Bye-bye.